So the next thing is we found some actions of the attacker here, but we have not yet found out how they got the ability to execute code on our server. So that's what we're going to do here. We're going to find the brute force attack. So let's start with finding the post events. So here we are with stream HTTP. We're not going to assume that that's the client IP, but we do want to find post events, and I'm going to turn on sampling to make it faster and get all the HTTP events. Now if you go down here, you'll see HTTP method, which is here, and it's typically post or get, and get is typically used to view something, and post is used to send up data, like when you're logging in. And apparently the attacker was able to log in and execute code on our server, so we want to look at these post events. All right, and I've got 160, and my instructions say I should find 15,570, which is appropriate because I'm doing 1% sampling. So I want to exclude the events from the vulnerability scanner and then look at form data. So to get rid of the vulnerability scanner, we can just put not in capitals and then Acunetics. That will just mean that string cannot appear anywhere in the event, and that should get rid of the vulnerability scanner. And that would give us a much smaller number of events, just 6. So I think it's time to turn off the sampling and see them all. And there's 509 events like that. Or 441 events like that. All right, good. 441 sounds like a familiar number. All right, now let's look at the form data. If we go down here, it's posts, and there should be form data, at least on some of these events. Let's use this thing here. Here's the form data. So some of them are loading a directory or something. Some of them are installing a package. That's disturbing, but that must have happened after they logged in. And here's ones that are trying to log in. No, I'm not seeing them either. So right now, this form data is not helping me much. So I need to see all of them. It only shows you the top 10 by default. So you can click top values and get a report in Splunk. This is one way to see everything that's happening here. It gives you a bar chart, which is not very helpful, but the statistics tab is pretty good. And here, I notice now I can see some stuff. Username is admin, login, password is ZXC and some junk, then password is yellow, password is Yankee, password is Yamaha. There are multiple login requests with all different passwords. This is a brute force attack. So I can see some of it here, and I could see them all by changing this limit to, say, 500. And then I will see all the requests. And I can see it tried many passwords. A more useful chart I've found to do this is to make a table. So instead of doing top limit, you do table, and then you choose the fields. And I would like the time and the form data. This will give me a nice chart with the time and the form data, and you see some of them have no form data. So it would be good to restrict ones that really have form data. Equals star. I think that'll do it. Yeah, that gets rid of the ones that don't have form data, and it shows me the ones that do have form data and the time, and I can sort the time here. So if I do that, I'm now counting up in time, so I can see the whole history of this attack. At 14:45, 21.226 seconds, it tried to log in with this password 1234567 Then a tiny fraction of a second later, it tried again and again and again and again and again, all in the same second. So at the rate of many attacks per second, it's trying all these different passwords. Let me in, and QWERTY, and 123, and so on. That's the brute force attack. And I can follow it. That's the first page of it. There are a total of 429 events here. So if I look at the fourth page, it's just more of the same. I got hot dog and happy and stuff. And the fifth page, I'm still doing password is private and so on. But if I scroll down here, you'll see the last password it tests is here. Now this was 1448.05. And the whole attack started, okay, 1448.05 is when it ended. And 1445.21 is when it started. So it looks like it took about 3 minutes to get to there. And I think if I look more carefully, I'll see it's even less time. 45.21 and 46.50. Following the time, 46, there's a jump from 46 to 48. So here is the last part of the brute force attack, which we'll see more in a minute. And this is a minute and a half later, another login comes in. And then this is apparently the right password, Batman, and because they now start performing administrative actions like installing an action, installing a package, changing a directory. This is apparently where the bad guy got in. So we see the brute force attack, we see the bad guy getting in, we see them doing administrative actions, uploading what is actually a PHP shell here, which they can then use to deface the web server. And another way to see that is to just go back to the original data here and look at the user agent. So we have these events, and we look at the HTTP user agent here, and you see there's 412 events from Python, running a Python script. That's the brute force attack. And then there's 17 events from a real browser, Mozilla. So this is the brute force attack that the attacker ran, and then it found the right password, and then a minute and a half later they logged in using a browser and manually started executing events. So this will give us the brute force events, and it would probably be easiest to just have that table again. Table time, pipe table, underscore time, comma, form data, form underscore data. That'll give us just the interesting information without a lot of unimportant stuff in the way. So this is the brute force attack itself, and it goes from 45.21 to 45.21. Looks like it's not sorted. Let me sort it. Okay. 46.51. So about a minute and a half. From 45.21 to 46.51 is this brute force attack. And if we look at the other ones, which will be get rid of that and get rid of the user agent, and look at all the post events that did not come from the vuln scanner. And if you look at HTTP user agent, the other one with the real browser, these are the 17 events that the attacker used once they got in. And again, I think a table is the easiest way to look at this. Table of time form data. And it remembers I've been using that, so I can just click on that in my history. And now I can sort it. 48.05.50. Okay, here's what they did. They logged in. This is apparently the right password, Batman. Now they installed a package with the PHP shell, and then they did these other events here. So now we've learned quite a lot more about what happened here, and we've pretty much gotten to the bottom of this brute force attack. We know how they achieved execution and what they did pretty much. And they uploaded an executable file to the server. So let's take a look at this. One of these apparently uploaded an exe file, and we might be able to see it here, but it might be in another field. So let's try adding exe to this. There is one event that uploaded an exe file, and here is destination content and Explorer. Well, I'm not finding it easily. Let me go back to my hints. So I said to find the exe, find these, exclude the events from vulnerability scanner, and look for executable file name extensions. So maybe it didn't have form data in that one. So let's get rid of the user agent and the form data constraints. There. That should do it. exe, but not act. Yeah, now there's 2 events. There was one I was missing with those other constraints. And so here, I think it's the, oh yeah, here's the other one. There we are. It is uploading this file, 3791.exe. That's a file it uploaded to the server. This is a Windows executable being uploaded in binary. All Windows executables start with MZ, and they've got a lot of null bytes, and here's some kind of binary data. That mess is uploading an executable, and there's the executable file name. And by the way, you can even use open source intelligence to learn more about that file name. You can go to well, you can do it when we get the hash, which I'll do next time, but that's the, anyway, that should get you started. Now we've seen what they did. And we'll talk more about how to use sysmon to analyze the execution of that file in the next video.